Hi everyone, so in this video we are going to be talking about quadratic functions, and in particular we're going to look a little closer at graphing these functions. So there's two different forms that we are going to look at, and the first is called vertex form, and it looks like this right here. And that should look a little familiar because it's kind of the same thing that we did for transformations. We still have that h and that k that's moving the stuff around. We're also going to have an a on the outside. So that a is going to stretch it. But for this, we're not going to have to worry about what stretching means. What we're going to do is we're going to find a few different things about the parabola and we're going to use those to graph it. So the first thing that we're going to find is called the vertex. So the vertex is the maximum or minimum point on the parabola. It's where it turns around. So for this parabola on the left, if you notice, it has a minimum point. That's the vertex. The parabola on the right has a maximum point. That's the vertex. It's wherever it turns around. And luckily, whenever it's in this form, it's really easy to find that. All you have to do is take that h and k, and that's your vertex. Now, keep in mind that says x minus h. So if you have something like x plus 3, then you just want to take the opposite sign of whatever's there. So in this case, h would be -3. So it's just something to keep in mind. The axis of symmetry is a line where it splits the parabola in half to where if you fold it over that line, it would match up with itself, right? So for example, on the one on the left, we have an axis of symmetry right here at x equals -3. That's where you could fold it in half and it'd match up. The one on the right, we have an axis of symmetry right here at x equals 1. And again, same thing, you could fold it in half. Right? Luckily, the axis of symmetry is also really easy to find. As long as you have the vertex, it's just going to be x equals that h, or the x coordinate from the vertex. All right, third part is we're going to figure out which way it opens. So normally, if there's no negative on the outside, the parent graph of the parabola opens upwards, like the one on the left. The only thing that made it open downwards was if there was a negative on the outside. That, if you remember, did a vertical reflection. So what that means for us is that if the number on the outside of the parentheses is positive, it'll open up. If it's negative, it'll open down. Next, the x-intercept and y-intercept. For those, you just set the other variable equal to 0 and solve. So for example, if you want the x-intercept, then you set x equal to 0, or sorry, y equal to 0, and you solve for x. That would be these points right here. If you want the y-intercept, you set x equal to 0 and solve for y. And that will give you the point where it crosses the y-axis. Using all of these, we can get a pretty good idea of how it looks, and we can sketch the graph. All right, so let's go ahead and try one. So we have -2 times x minus 3 squared plus 8. So first off is the vertex. Remember, vertex is nice and easy. It's just going to be the opposite of the number with x. So if it's -3, then it's going to be +3, comma, the number at the end. So 8. So 3, 8 is our vertex for this one. I'm going to go ahead and put that on the graph. The axis of symmetry is always going to be, oops, no parentheses, x equals whatever the x part of the vertex was. In this case, it was 3, so x equals 3. Gets us an axis of symmetry right there. Next up, opens. We have a negative out front, which means it's going to open down, which means it's going to be an upside down U shape at the end. Next, the x-intercept. So for x-intercept, we're going to set y equal to 0, or in this case, f of x equals 0, and we're going to solve for x. All right, so we have negative 2 times x minus 3 squared plus 8 equals 0. You can solve this however you want. In this case, I'm going to use the square root property, just because I see a nice thing that's squared. So we can take the square root of both sides if we can isolate that. So I'm going to subtract 8 from both sides. So that's negative 2 times x minus 3 squared equals negative 8. Divide both sides by negative 2. Get x minus 3 squared equals 4. And then I'm going to take the square root of both sides. Just don't forget, if you take the square root of both sides, then you need to add a plus or minus to the side without x. So from there, we have x minus 3 equals plus or minus 2. Lastly, we can go ahead and add 3 to both sides. So get x equals 3 plus or minus 2. And since we do actually want both of those numbers, we're going to split out that plus or minus. So we got x equals 3 plus 2, which is going to be 5. So that is 5, 0. And we also have x equals 3 minus 2, which is going to be 1. So 1, 0. So 1, 0, 5, 0. Got both of those on our graph now. Next up, y-intercept. So luckily y-intercept's always a bit easier than x-intercept. So this time we're going to set x equal to 0. So we have negative 2 times 0 minus 3 squared plus 8. 0 minus 3 is negative 3. So that's going to be negative 2 times 9, which is negative 18, and that's going to be negative 10. So 0, negative 10. And our graph doesn't quite reach that far in this case, but we'll go ahead and say that that's 9 and 10, so somewhere right down there. All right, so before we do the domain and range and all that stuff, let's go ahead and just sketch this out because we have all of our points on there. So it should look something like this, and it's going to be going down very quickly. All right, for domain, it's a parabola. It's going to be negative infinity to infinity. Our range, though, bottom is negative infinity. The topmost point is 8 in this case. Then it asks if we have a maximum or minimum value. So in this case, it's a maximum because we have a top point, but we don't have any bottom point because it keeps going down forever. So we have a maximum of 8. Next, increasing and decreasing are very similar to domain and range in that we're going to write them in interval notation. And we just say where it's increasing from left to right and where it's decreasing from left to right. So in our case, it is increasing from negative infinity all the way up to 3. Because all of this part, all of that is increasing from left to right. Then it turns around and it starts decreasing from left to right. That happens from x equals 3 to infinity. All right, let's go and look at another form. So our next form is standard form, and in this one it's a little harder to find the vertex, but in my opinion it's a little easier to find the x and y intercepts so long as you know how to factor, assuming it can't be factored, but most of these will be able to in this class. So for the vertex, that's a little formula. So it's negative b over 2a. That's the part you really have to remember. Negative b over 2a. Comma f of negative b over 2a, which just means that you're going to plug in the x value. That'll get you your y value. That's all that means. It's not another formula. Just means plug in whatever you got as your x value. Our axis of symmetry, again, it's going to be the same thing as before in that as soon as you find your vertex, the x part of your vertex is going to be your axis of symmetry. So it's going to x equals whatever that was. Opens up or down is going to be the same exact thing. We're just looking at the number that's attached to x squared. If that's positive, then it's going to open up. If it's negative, it's going to open down. And the x-intercept and y-intercept work the exact same way in that you set the other equal to 0 and then solve. All right, so let's try one like that. So first off, the vertex. So it's negative b over 2a. And remember, this is just a is 1, b is negative 2, c is negative 3. It's just the numbers without the x. So negative 2 would be positive 2 over 2a, so 2 times 1. So that's 2 over 2, or 1. That's part of our vertex. So it's going to be 1 comma something. Or I guess I should write it down here where I actually left a spot for the vertex. So it's 1 comma something. To find that something, all we're going to do is we're going to plug 1 into the function. So it's going to be 1 squared minus 2 times 1 minus 3, which is going to be 1 minus 2 minus 3, which is negative 4. So 1 comma negative 4 is our vertex. So I'm going to go ahead and put that one there. Axis of symmetry, again, you don't really have to think about it. It's just x equals the x part of the vertex. So in this case, 1. Opens up or down. In this case, a was positive, so it's going to open up. All right, so let's go ahead and put that axis of symmetry on here, just so we can easily see where that turnaround point is going to be. All right, x-intercept is next. So for the x-intercept, we set the function equal to 0, and then we solve it. So our function, again, was x squared minus 2x minus 3. And we're going to be setting that equal to 0. So again, solve this however you like. In my case, I would factor it. So our a times c is -3. Our b is -2. So we're looking for numbers that multiply to -3 and add to -2. In this case, that would be 1 and -3. So x plus 1, x minus 3. We can set both of those equal to 0. And we would get x equals -1, x equals 3. So -1, 0, and 3, 0 are 2x intercepts. And we're going to go ahead and put those on there. Y-intercept is much easier, because if we plug in 0 for all of this stuff, so we got 0 squared minus 2 times 0 minus 3. If you notice, 0 times anything is just 0. So all we're left with is -3. So 0, -3 is our y-intercept. All right, again, we can go ahead and draw this out now, just so we have an idea of the shape before we do domain, range, increasing, decreasing, all that stuff. And one little hint, just to make sure that it's symmetrical. We know this y-intercept is right here. Well, if that point is 1 to the left of what we said is our mirror, there should also be a point 1 to the right of our mirror. And that'll just help us draw the shape a little bit better. All right, with that said, let's go ahead and draw the U. And then we can do domain, range, min-max, increasing, decreasing. So domain first. The domain, again, it's a parabola, -infinity to infinity. Don't even need to think about it. The range, though, the lowest it goes is -4, and the highest it goes would be infinity. In this case, it has a minimum, and that minimum is at -4. Then where is it increasing? So this time, it's increasing over here, because remember, we look at it left to right. From left to right, this is going up. So that's where it's increasing. So that is from 1 all the way out to infinity. Then decreasing, it's decreasing over on this side, because again, from left to right is going downwards here. So that means it is decreasing from -infinity to 1. All right, just a little more practice here. But since this video is starting to get a little long, we'll go ahead and save this for part 2. So I will see you in part 2 of this video.